Dr. Gail Iles. I'm a research fellow for the European Space Agency, and I'm here with a team from IFAM in Bremen, and we're flying a nickel evaporation source. We're evaporating nickel in an atmosphere of argon, and this is to create agglomerates that will form during an aerosol stream, and these will eventually be deposited after 40 centimetres of travelling time onto some substrates that we can subsequently remove and analyse to see how the particles are formed within microgravity and perhaps in the 2G phase as well. There are 3 racks with our experiment. We have the main rack where the magic happens, and we also have a power unit and a water cooling unit. What we're doing is we're evaporating nickel. This requires very high temperatures and a lot of power as well. We have an induction coil heater, which is a non-contact type of heater. We need a lot of power, which we take from a UPS unit, an uninterruptible power supply. And we also have to then cool the system down so that it doesn't overheat. So we also have a water cooling unit. Well, we're melting nickel, and it's in a liquidous, a solidus state, so it means that we're affected by things like convection and sedimentation. Sedimentation is the effect where big things fall to the bottom and the small things rise to the top, like you would get in a river, for example. And then in our experiment, by performing in microgravity, it means that we reduce the effects of convection. We have an aerosol stream here, and on Earth, the stream is affected by turbulent flows and a non-constant aerosol stream. In microgravity, we reduce all of the convection effects. There's no sedimentation of the particles. And what we find is that when we look at the particles, once we've taken them out of the chamber, is that the particles have all formed in the same size. And we don't see this in the lab at all. And this is of great interest both scientifically and also industrially. This research is very applicable. It's part of the IMPRESS project, which has 2 main research areas. The side that we're working on is the nickel side. This is work related to the catalyst industry, and the nickel particles that we're investigating will be used in hydrogen fuel cell technology. This is one side of the project. The other side is the intermetallic titanium aluminium, which is used, or we hope to use, in the next generation of turbine blades.
20, 30, go.